Welcome to Spring LIB.
This is the answer to Chapter 12, problem number 45 from the Smith Organic Chemistry textbook. And this problem starts by giving us this molecule and telling us that when it's treated with deuterium gas and palladium on carbon, the deuteriums both add from the top and only from the top. And so this is important because it tells us that the bottom face of this molecule is blocked. It's hindered. And so anything that adds is going to add from the top. So when we're then asked to predict products for the other two reactions or series of reactions that we're given, we can do so because we know that the bottom face of this molecule is blocked. So for example, for A, the MCPBA is only going to be able to add from that same top face that the deuterium added from. And so the product here is going to look like this. So here's our molecule, and the epoxide here is going to be up. So the epoxide is going to look like this, right? Because the MCPBA can only add from that top face. So it's going to add from that top face there. So now, in part B of this problem, we're asked to do a series of reactions that are also going to have us end with an epoxide. But it's actually going to be the opposite epoxide to part A here. And so the reason for that looks like this. So we need to think about this mechanistically in order to see that's ugly. We need to think about this mechanistically in order to see why it makes sense that we're going to get the opposite product from this series of reactions. So after the bromination here, we're going to have this bridged intermediate with the bromine in it. And that's also only going to be able to have added from the top. So there's our bromine. It's going to have a positive charge on it. So there's our bromine. So now when we next treat this with water, or I guess we used water at the same time as the bromine. Regardless, there's water in this solution. So the water, the oxygen is going to attack from below. So it can attack either of these carbons, but it's going to come from below. And so that's important because the two possible products that we're going to get here, in both cases, the OH group is going to be below the plane of this ring. And so give me a moment and I will draw exactly what I mean. And hopefully it will be more apparent then. So we can have a scenario where our OH added to the nearer of the two carbons. So we now have a hydrogen here. And then in that case, our bromine is going to be up here. Or we can have the other possible scenario. And of course, in truth, we're going to get a mixture of these two products. And so the other scenario would be that our alcohol has added to the other carbon, still from the bottom, so still down here. And then our bromine is still going to be in the up position on this other carbon. So we'll have a hydrogen here this time, and we'll have a hydrogen here this time. And I guess just for the sake of completeness, I'll include the hydrogen there as well. Okay, and so this is important because in either of these cases, our final product after treatment with base, so after we treat with base, the oxygen is going to intramolecularly attack the carbon with the bromine on it. It will displace the bromine. And so we'll end up with this opposite epoxide to the one that we formed in part A. So this epoxide here, where the epoxide is down, and that's going to happen because the oxygen has to come from below, right? So the oxygen is either going to come up here and attack that carbon and displace the bromine, or it's going to come down here and still come up and displace the bromine. So in either instance, we get this epoxide facing down. And so that's sort of what this problem is trying to show, is that we can make either of these two epoxide products. Obviously, if we want the one with the epoxide facing up, it's much easier. We just use MCPBA. But if we want, selectively just the epoxide facing down, it's still possible to get there. We just have to use a couple steps to take advantage of the fact that the bottom face of this molecule is blocked. And so that's the answer to chapter 12, problem number 45.